We have these slides posted up at graspablemap.com/unconf-slides. So if you don't like copying and pasting things from the chat, you can just go there and grab the links, and that'll make things easier to click through as we go. Thanks so much, everybody, for sticking with us through this day of really exciting talks. I've been seeing a bunch of cool stuff. Our talk is going to be about algebra and algebraic symbols. So not just algebra content, but every place that you're using sort of mathematical symbols to go through transformations. That's really our focus at Graspable Math. And one thing that I want to sort of emphasize or sort of say at the outset that was part of our motivation was thinking about these symbols as objects that move in space and that tell a story. And we're really interested in how we help learners see that bigger story, how we help them focus on that bigger picture of what's going on. So, you can think about a factoring or distribution instance like this as, of course, the sort of structure that it represents, and also as moving that 3 into the parentheses and distributing it across, and moving that 3y by subtracting from both sides. We get that 3y over to the other side in order to isolate that variable, in order to cancel that y out. So part of the story of this derivation is that the y goes away, right, and sort of disappears. And I think this was really nicely captured actually just in the previous talk, thinking about things like the idea that when all the variables cancel and you're left with a true statement, that means there's infinitely many solutions, right? There's a meaning to that broader structure, that bigger picture. And part of what we're really interested in is connecting that bigger inferential picture to the symbols themselves. And I just want to be clear, not necessarily thinking here about connecting the meaningful situation that you're dealing with. I think a lot of people are talking about that. That's great. That's super important. We're really interested in how do you work with and make sense of these symbols and understand them. So I'm going to show you, jump right in and sort of show you one of the technology that we've built to do this. You can follow along here if you use this link, or it's the third link in the things that I posted over in the chat. And I'll just show you when you load that link. So you can go ahead and load it now. You should get to a page like this. And you can put in your first name, last initial. That's sort of a suggestion. You can put in whenever is kind of appropriate as a signifier. And in fact, I will just grab this 7NTEK and put it there. And now it'll let me join since I didn't delete this one. Okay, so what you can see here is a set of activities over on the left. So they're going to be 8 little things I'm going to show you through, and then an expression here. And the important piece of this to understand is that for us, expressions are fully digital objects. So you can manipulate them, and the rules are kind of built in as fully manipulable objects. So here you can pick up this too and move it around in ways that are mathematically valid. And actually what I'm going to do here is very simple. I'm just going to click on the plus sign. And you see that turned green because it matched the goal. So in this particular mode, it's kind of an answers in the back of the book mode. You know what the answer is you're trying to get to. And the question is, how do you manipulate this expression into that format? So here again, you have an expression. It looks like an inert expression, but it's not. It's sort of encapsulating the motion dynamics, the story that that expression can tell. And you'll notice also when I picked up this term, there are a bunch of little blue boxes. Those are all showing you places that something would happen if you put it there. And you can kind of think about what's going to happen if I drop it here. Well, then I apply the commutative property. And some things I can't do. I can't just move this 3 out to the side, right? And I'll show you over here. I can't just add this 2 plus 3. Right? That violates the property. And so I can discover that by saying, okay, it's not working. And in fact, sometimes students will interact with our system and say, oh, I think it's broken. It's not letting me add the 2 plus 3. And that's a great moment for a conversation about what's going on. What are the rules and structures that they're forgetting about? In that case, it's, PEMDAS. Okay, so I'll go on to the next one. And just show you, okay, we can do a bunch of different things. Here are a couple other examples. Oh, and one thing I wanted to show you, there are a number of ways, and this might be tricking some people. So if you're having troubles, please go ahead and put them in the comments, or if you have comments or thoughts. So you'll notice the thing I'm doing is grabbing this plus sign. That lets me pick up a whole chunk. I can also pick up a whole chunk, and sometimes it's convenient by just grabbing a piece of it and pulling down. And you can see this kind of grabs its neighbors along with it. And in fact, if I go down farther, it'll pick up a bigger and bigger set of neighbors. In this case, that's just the whole expression. So that kind of gives me a sort of way to understand, okay, what is that larger structure? I'll go ahead and just run through and say, okay, I'm going to go ahead and combine these. I know that I can. That's one way to do it. Another way to do it is you can see this blue box here. I can just drop the 7y on top of the 2y, and those will combine. and then give you a sense of the kind of scaling that you can do. We actually go fairly low and fairly high in terms of working with symbols, but you can do things like the distributive property. So here you can see I can move this 2 over to the other side. That's my commutative property. I can also drop it in, and I can distribute into that expression. And similarly here, I can distribute into that expression. There are different modes. You can make this kind of more automatic or less automatic. And this one, I actually now have to come through and multiply and say, okay, I know what that's headed toward. I have to sort of verify that I understand what transformations we're doing and what should be appropriate or allowed. So there, okay, go ahead there. I'll show you a couple of more things that you can do. So here you'll notice there's an division, and we want to get rid of that division. There are a couple of things we can do. One, because these are denominators, we can, and you can see the box there, we could break this apart and separate it out into 2 fractions. What I'm actually going to do is just simplify it a little bit. I'm going to drop this 4 onto this 8. And in this mode, it will just tell me, okay, great, there's a common factor of 4. So as long as I know I'm looking for that common factor, I can find it by engaging in this relatively straightforward manipulation. And again, our hope is what this lets you do is when you want to focus on that bigger structure, you can. Oh, and I just skipped right through. So I'll say out loud, a thing I'm doing here is taking this 4 and dropping it on top of the other 4. And that's my action to sort of signify, I know I want to cancel these terms. You can continue to do this in sort of larger contexts. Again, you can see it's a pretty easy system, we hope, to manipulate once you get practice. You might be having a different experience, and I just want to emphasize, it often does take a little practice to kind of get the hang of it. So I will go ahead and do this. And one thing I want to note, I'll do a couple more, but I also want to notice that a bunch of you are already doing this activity, and I can see that. By looking over here, I can see that a number of people have submitted solutions to each of these activities, and we'll come back to that. But for now, I just want to show you the little pieces. We'll go ahead and finish this up. At this point, I think you've gotten the idea. I'm just finishing it for myself at this point because it's hard for me to leave a thing half done. So we'll finish. There we go. And you'll notice here, you know, the goal rate, that could be whatever you want. In this case, we put them into pretty normal forms. All right. Great. So that's all the activities in this particular little bit. That gave you a little bit of practice. What I'd like you to do now is just give me some of your responses. So we're going to pause now and go into breakout rooms. What I'd like you to do is just say hi and introduce yourselves, have a chance to talk, and talk through some of your responses or reactions or concerns, some of the things that didn't work or that did work, and then we'll come back together. If you want, if you run out of things to talk about, here's a slightly harder activity, which I'm fairly sure still works and I didn't delete it. So copy that link down, and I'll go ahead and copy it into the chat right now. Whoops. And then when we come back, I will give you some of our thoughts and reflections about where we think this activity fits and kind of where we think its value is. But for now, I'll give you 3 minutes, maybe just a little brief time to talk with each other. And I was going to discuss a little bit of how we think about this. So some of our reflections and motivations in building this come out of thinking about children's learning, and especially learning through doing, learning through interacting, learning through manipulating things. So if you want to learn that things fall down, to learn about structure, a great way, not the only way, but a great way is to play with blocks, to play with toys, to play with things that fall and watch what happens. And one perspective on what's so hard about algebra, one thing that's so hard about algebra is when you make a mistake, the world doesn't tell you you're wrong. It just lets you plow ahead with whatever thing you're doing. And the paper won't tell you you're wrong. You don't find out you were wrong until a day or a week later when you get graded. And so part of what we're doing is creating this environment where a person can find out the results of what they did, right? And they can look at it and say, oh, that wasn't what I expected. It can be a moment for reflection, a moment for understanding, to see what the result of an action is, and then do some sense making from it. All right, so another way to think about this that we thought a lot about was thinking about learning chess. So let's imagine you wanted to learn how to play chess, but the only way you learned to play chess, you didn't have a chessboard. The only way you could learn was by drawing out the map. And then when you wanted to make a move, you would just redraw the board, but you'd draw the board with another piece moved. And then if you wanted to make another move, you'd redraw another board. Well, as you can imagine, if you were doing this over and over and over again, first of all, this might be a great way to learn basics about how the pieces move. It might be a useful exercise. It might be a good thing to do, but if you really wanted to learn how games worked, it would be a terrible way because you'd spend a lot of time with copying mistakes. You'd spend a lot of time moving a pawn, but also leaving it behind in its old location, or just being off by one, or all kinds of other very small, important, crucial to making the game work, but small scale concerns. And it would be very, very hard, we think, to focus on the big picture of the structure. And so we think that's exactly the situation in algebra, right? You want to understand how the pieces move. You want to understand those basics. You also want to have a chessboard so that you can see what happens. You can't actually move a pawn and also leave it behind. You can't do these sorts of things, and you can kind of explore. So that's what our sort of thinking about Graspable Math was, that it's this way of seeing some of this structure in a physically informative, quick feedback way that lets you do some reflection and some thinking and also have that focus on the larger activities. Speaking of the word activities, what I'm going to do now is show you this activities website. This is brand new, so it's not, I'm going to say some of the features are kind of in process. We're still really developing it. We really released it right now for obvious reasons related to COVID. We just wanted people to have it available, and we knew we had something that could be useful to some of our partners, but we think it's useful enough that we wanted to share it with you and see it's a way of accessing general Graspable Math in an easy way that hopefully is suited toward class contexts. So what I'm going to do now is show you through how to make these activities, how to work with them. And oh, actually, before I do that, I just wanted to show you a couple of resources that are linked here and that you can find on our webpage. These are just places you can go to find some of the frequently used gestures. So this gives you some instructions if you were in the situation of saying, how on earth do I do this or this or this? This is some instructions that show you some of those things you can do. It shows you, I noticed someone in the comments mentioning that moving the numerator and the denominator can feel counterintuitive. There are various actions that can feel intuitive or counterintuitive. This is an attempt to kind of summarize what some of those actions are. And we also, if you go to graspablemap.com/learn, have some tutorial videos that take you through in a different way how some of those activities work. So there are some learning resources to figure out, okay, how do I do the things that I want to do inside the system? All right. And then what I thought I would do next is just take you through on a little walkthrough of how to create these activities. So what I did was made an activity for you to look at. So I'll bring my screen down here. And what you want to do, if you want to follow along, is go to
activities.graspablemap.com.
We do Google sign-in, so you should have a sign-in screen. I don't have it because I'm already signed in, but it should just take you in to this kind of page. And I'll take you through a couple of the features that there currently are. One is a set of activities. If you click on that activities, these explore ones are activities other people have chosen to make public. So some of them are created by us. Many of them are, the recent ones are created by teachers who are using the system. We also have a little set of ones that we sort of proctored and think are kind of useful in elementary introductions or sort of generic introductions. And then the really exciting one is My Activities. So here you can create your own activities. You can also get them from other people's by clicking on an activity and saying copy the activity. Once you do that, it'll put a copy of it into your own activity bank. So if I go to My Activities, now I'll have a copy of that one. I don't actually want that one at this moment, so I'm going to go ahead and delete it. And then, oh, and I noticed someone asking if it's free. So it is free for now, for sure. And then we're not sure about the future. Also, I'll mention the Graspable Math, the main page, is free forever. So we intend to make this Graspable Math page free. And there's a canvas you can go to where you can enter single expressions. So that's the current state of things. All right, so in these activities, what I'm going to show you first is how to make one and then what you get out of them. So to create an activity, you're just going to say create activities. You're going to say what the name of your activity is and create that. And then you're in this sort of blank space that says, okay, maybe I want to add something, but I'm not sure what to do here. What I can do is add an activity. I'm going to add a goal state activity, which is the kind you were just doing. And what I do is just say, okay, what's the starting state? I'm going to make this one easy. So I'm going to say the starting state is 4 plus 5. And I think you all know the answer. Does anybody know the answer? So it's going to be 9. And then I can put in special instructions if I want to. So I could link out to some help documents. I could link out to some teaching or resource materials. The normal thing is just make the expression match the goal. That's the default text. I will say my daughter's feedback on this was that we should change that every time, because she said after 2 of them, she just stops reading it. But anyway, then we have an activity. We can edit it, we can delete it, we can do whatever we want to. We could add more if we want to. There are various different kinds of activities we can add. In fact, I'll go ahead. I think we've got enough time. So I will show you a Canvas activity. This is a much more open and free-form space. It's our old Canvas sort of interface. So here, if I want to insert a math expression, I do it by hand. And I will say, let's make this. This is very useful when you want to have either an open forum where you don't want to say what the answer is, or a case where you want to have, say, multiple equations. So if you want to have multiple equations, oh, I meant to make that one, don't mind me. I meant to make that one depend on y, so I will go ahead and do so. You can do various things like that, and this lets you have quite a bit more power and flexibility. Again, I think I've got enough time, so I'm going to also mention that you can, in this situation, connect with GeoGebra so that you can do things like graph your lines, right? And in fact, oh, sorry, so the canvas, to get to it, I saw Denise asking, a good way is to go to the activities. As you're creating the activity, just select Canvas as the activity type. And that'll give you this Canvas activity. So that's right here under the new task type, you would say Canvas. Whenever you have enough activities and you feel happy with what you've got, then you can, first of all, if you want, you can rename it. You can give it a description. If you just click, here what I did was clicked on this name, my first activity. And if you want to share it with other teachers, you can click on this public button. That's not for sharing with students. Students can find it regardless when you make a session, but this is to share it and let other teachers find it and duplicate this activity. I'm not personally super proud of this activity, so I'm not going to make it public. But we hope that people are already creating great things and sharing them. So hopefully some more. And now what I can do if I want to share
I
this
want to show
activity.
scrubbing on that canvas.
Oh, let me show that in the other situation where we're using it. So, okay. So now if I want people to be able to use this, my students to be able to use it, I need to make a session. So I make a session, that's a thing that live students can actually join. So it goes from being an edited thing that we're perfecting to being something that my students can actually go to. So in fact, I will just copy this link into the chat and show you, you can all go to this activity we just made. There it is. And again, it'll ask you to enter your name. So right now there's no student login side. Teachers log in, they see the information. Students just go in and enter their identifying information to you, so that you know who's who if you want. And then they can go ahead and do them. So it's very low stakes on the student side at this point. And now let me just show you, I'll go back to our other session that we had and show you a thing we were doing in the chat rooms that I think is a nice power. So here is what I see as a teacher. If I've created the session, this is the session you all did at the very beginning, and I can see immediately how many people have worked on it, how many people have gotten it complete, and for each person who signed in, how far they made it through the activities. So I can see a bunch of you made it quite far, a bunch of people made it all the way through, some people just barely started it. And I can also look and see what everybody's doing, and this happens in real time. So I'll go ahead and look at one here. I can see each individual's work and the steps that they took to go through the problem. In one of the breakout sessions, actually, a couple people were having trouble with this problem in particular. It's one that you kind of have to get used to be able to manipulate. And I can look at what you've done so far and be able to say, okay, and what I can do in the breakout room is say, oh, okay, I see where you're at. Go ahead and click on this and then move this over here, or here's a nice sort of thing to do. So that lets me sort of get at everybody's work. You can see, I can see here coded who solved the problem, got to some solution, who started the problem but didn't get all the way down to a solution, and who hasn't yet started the problem. So who didn't get this far. And that lets me really sort of see who's working at what place and help people, like I said, hopefully in real time and certainly kind of after the fact as you like. So once you've got a session live, you can go ahead and see that for anybody who's entered into it or for any of your sessions. So I'm curious just because I'm looking in. Okay, so a bunch of people have actually started the session we just did. That's awesome. And we'd be able to look at the work that you're doing in there too. And then Ludlow, it's a great point. Let me go ahead and show you a couple of things Canvas that just gives you a sense of the flexibility of the canvases. So I'll do this in preview mode. Oh, in fact, instead of solving that one, I'd like to just go to this one. So here's the problem that I set up for everybody. And I thought I'd just show you, again, some of the power of what you can do here. One thing you can do is you can adjust the numbers in what we call scrub mode. So this lets you kind of change what the numbers are. And that's fine. That is what it is. But I think it becomes very powerful when you're in a derivation. So here I'm going to go ahead and solve for x. I just made this expression up, so it's not going to solve in a nice way. But what I'm going to do is put it in and substitute it into the other expression. And again, these are all pretty advanced features that I'm showing you right now of things that you can do. If you want to learn how to do them, you can go to those learning pages and hopefully get some good instruction about how to do these various actions. Oh, and in fact, I'll show you one thing, which is you can set a lot of parameters. Oops, you can set a lot of parameters. One thing you can do is make sure that students have to subtract 6 from both sides. Another thing you can do is have a shorter mode, and this one is set into that mode, where I can actually just click and drag. So if your students know that step, if you feel comfortable, you can let them click and drag. If you don't feel comfortable with that, if you don't want them doing that sort of thing on their own yet, then you can set it to a less automatic mode where they have to actually do the subtraction for themselves. And oh, a couple other features that people were wondering about. I just want to mention it again. Here, I want to pick up this 80y. How can I do that? Well, what I can do is click on this, drag down till I get the whole 80y, and in this case, pull it over. Okay. Oh, sorry, I wanted to show you now the power of this scrub mode. So now I can go back and say, what were those original problem steps? And I can say, what would it have been like if that 5 was a 6? What would have happened to my equations, and what would have happened to my x and y values? So once I've gotten my solution, I can see how the solution depends on each of the original problems in the expression. Cool. I'm just taking a second to check over whether there are questions. Okay, so those are the kinds of things you can do in here. What I'd like to do now is just give you all a minute again to kind of try it yourselves. So what I'd like you to do is go to activities.graspablemap.com if you want to in your breakout room. Try to help each other. I'll try to move between breakout rooms and hopefully we'll have some helpers in there to help you out. Just try to make a simple activity, and if you would, try to share it in your breakout chat so that you can try each other's activities and see that information kind of coming in so that you can see the teacher view as students work on problems and kind of get a sense of that, that pacing. So yeah, can we go back into the, is it possible to go back to the same breakout room?
Might be larger breakout rooms, actually.
Oh, sure. So I'm going to wrap up because we're right at time. My hope is that at this point you are sort of excited about Graspable Math, that you think it could be interesting. Hope people are talking, and we're hearing great stuff in the comments. Hopefully you've also seen that it takes a little bit of time and a little bit of a startup to figuring out how to use it and how to become sort of good at making those activities. I wanted to say a couple of things that came up in a couple of breakout rooms. One was some folks mentioned, I think this matches my experience. Often a good sort of way to work with this with students is to model it as a teacher, to have an activity or an interactive where you say, okay, here's what we're learning the lesson, and then have the students do something on their own that kind of mirrors that or builds on that. I think that's a really good kind of way. And I wonder if there are any other questions before we close here. We're just about out of time, but happy to answer questions that came up from the breakout. And if not, I'll just say, as you're playing with this, which I hope you want to and hope you will, just want to reiterate there's some great learning pages on the Graspable Math webpage that will show you how to manipulate, do different manipulations, and a walkthrough video on how to build activities at that activities page. Feel free to email us at contact@graspablemap.com or on Twitter at Graspable Math and somebody will help you out with any troubles you have. And then I will stop presenting here, but I'll hang out in the chat and answer questions if people want to write them as we go. And thanks, everybody.